Hello, this is Rubab, your audio navigator, and here I'm going to guide you about structure-reactivity correlations and organic reaction mechanisms. This is the last segment of the syllabus, but not the least. A lot of questions come from here, mainly 1 to 2 marks. So you need to understand and learn this topic very well, starting with the acids and bases. For this, you need to know what are the different theories defining acids and bases. First of all, the Arrhenius theory of acids and bases. According to this, what are acids and what are bases? With examples, and then what are the limitations of this theory. Then after that, what is the Bronsted-Lowry theory of acids and bases? According to this theory, how are acids and bases described? We need to go through also a few examples. Then what are conjugate pairs? You need to go through different examples for that. Then what are amphoteric substances? What are their behavior? Then after that, what is the Lewis theory of acids and bases? According to this theory, how are acids and bases described? What are Lewis bases? How do they act? Then what are Lewis acids and how do they perform? Then what are strong acids and strong bases? And how are acid strength, anion size and bond energy associated with one another? Then what are weak acids and weak bases and how are they defined? And after the acids and base concept, now you need to go through the electronic and steric effects in molecules. First, I will pick up the electronic effect. What is actually the electronic effect? And how does it affect a molecule? For example, it influences the structure, reactivity, or properties of molecule. Then what are the different types of electronic effect like induction? So what is induction? It is the redistribution of electron density through a traditional sigma bonded structure according to the electronegativity of the atoms involved. The inductive effect drops across every sigma bond involved, limiting its effect to only a few bonds. Then the other electronic effect, which is the conjugation. What is conjugation? How is it affected? It is not only affected by the electronegativity of the connected atoms, but the position of electron load pairs with respect to the system. The influence of the conjugation is extended further than the induction. Then the hyperconjugation. What is actually the hyperconjugation? And how the other phenomena like Gauge's effect and anomeric effect are explained by hyperconjugation. What is anomeric effect and what is Gauge effect? Go through these effects in detail and should also know what are the factors affecting these effects. With examples, another kind of electronic effect is the orbital symmetry. It is very important when dealing with orbitals which contain directional components like P and D. What are the different examples of this? For example, like pericyclic reactions such as Diels-Alder reaction. Then the another kind of effect is electrostatic interactions. Go through it. Then the other one is the van der Waals radii, hydrogen bonding. Another electronic effect is the electronic spin rate, which is the simplest, describes the number of unpaired electrons in a molecule. Most molecules, including the proteins, carbohydrates, and lipids that make up the majority of life, have no unpaired electrons even when charged. Such molecules are called singlet molecules. And in contrast, dioxygen, which has two unpaired electrons. Dioxygen is a triplet molecule as it has 3 spin states. Electron spin states are more complex for transition metals. So you should know and understand the concept of d electron configuration as well as high spin and low spin configuration. Then what is Jahn-Teller Effect, which is the geometrical distortion of nonlinear molecules under certain situations. Let's go through this effect in detail. Then what is trans-incurrence, which is the incurrence in a square or octahedral complex has on the bond to the ligand trans to it. Then what are steric effects, which arise from the fact that each atom within a molecule occupies a certain amount of space. For this you should be very well aware of the electronic configuration. What is poly or bond repulsion? Then what are the different types of steric effects? Like steric hindrance. You need to know what is steric hindrance and how does it act. An effect like it can also restrict torsional bond angles. And what is Debye shielding? Then after the next effect is the steric attraction. Just go through it with examples. Another effect is the chain crossing. What is its role? Like this effect is responsible for the shape of catenanes and molecular knots. Then another effect is the steric repulsions. What is the role of steric repulsion and how does it function? For example, it is largely responsible for the stabilizing of colloids by coating the surface with a polymer, and can also cause bond length shortening and compressional frequency enhancement in the IR spectrum. And then another effect is the steric inhibition of resonance. So go through this. What kind of molecule show this effect? Like it is only shown in benzene rings. One effect is the steric inhibition of protonation. So go through the concepts of all these effects with different examples. So after covering these effects, you should know what are the distinctive features of electronic effects and steric effects, and what are their respective significance. And you should do a comparative study of both of these. And after this, you have to go through isomerism. You should know what is isomerism and what are the different types of isomerism, like structural isomerism and stereoisomerism. Let's pick up first the structural isomerism. That too is also 5 types. First one is the chain isomerism. So you should know the concept of chain isomerism and the different examples for this. Same for the position isomerism with example. Then comes the functional isomerism. Then what is metamerism? And then finally what is tautomerism. So you should know about each one of them with examples. Then you have to cover stereoisomerism. That again is of 2 types. First one is the geometrical isomerism and then is the optical isomerism. So let's start with geometrical isomerism. For that you have to go through different examples for this. First you can take the alkenes. What are the cis and trans rotation forms of it? And the restriction of rotation about the carbon-carbon double bond is responsible for geometrical isomerism in alkenes. Then you should know that how geometrical isomerism is found in cyclic compounds. Also go through different examples. After this you need to know about optical isomerism. For that, you should be familiar about few terms like what is optical activity, what is plane polarized light, what are dextrorotatory and what are levorotatory, and what is the plane of symmetry, and how the objects are termed as chiral or dissymmetric or achiral. What is an asymmetric carbon atom? Then you should go through a few examples of optical isomerism, like in lactic acid, how it can be dextrorotatory or levorotatory or a racemic mixture. Then what are Fischer projections? You should also know about the Fischer rules for showing the arrangement around an asymmetric carbon atom. Just go through them. What are the conditions for optical isomerism? The necessary condition for a molecule to exhibit optical isomerism is that it should be disymmetric. I'm going to say dissymmetric. And what are the different optical isomers of tartaric acid? Like dextrorotatory, levorotatory, or mesotartaric acid, and the racemic mixture. So you should be very familiar with the terms used to describe optical isomers like optically active molecule, asymmetric carbon, enantiomers, diastereomers, racemic mixture, mesocompound, etc. Then you should also go through the properties of enantiomers, diastereomers, and mesocompounds. Then how the optical activity is exhibited in compounds without asymmetric carbons, for example in alene derivatives or biphenyl derivatives. So go through these examples. Then how the resolution of racemic mixtures is done. The methods are like chemical resolution, and the other one is the biochemical resolution. So just go through these methods. Then how the racemization is done. You need to study this with examples. Then how is the asymmetric synthesis done? Means the synthesis of compound containing an asymmetric carbon atom. Then what is Walden inversion, and what does the mechanism of Walden inversion involves? It is comprised of 3 steps, so you should know about these. So now that this, you should know about the RS system for asymmetric molecules. What is it comprised of, and to establish the group priorities the sequence rules are followed. So you should know about these rules. There are 3 rules, so you should go through this. Then what are the guidelines for specifying configuration of an asymmetric molecule by R and S notations? What are the different steps which are followed? Then what is the EZ system for geometrical isomers? As from the GATE exam point of view, isomerism is a very important topic. Questions are often asked regarding the different conformers of compounds, so your basic knowledge about it should be very good and your concept should be clear. Now next you have to cover the organic reactions and their mechanisms. So you should know what are the factors which influence a reaction. For example, the factors which influence the electron density in the substrate are inductive effect, mesomeric effect, and electromeric effect. So you need to go all through these in detail. Then what are homolytic fission and heterolytic fission? How are free radicals formed? What are the general reaction intermediates like carbonium ion? Then the carbanions or the carbon free radical, or there are carbenes. So go through these with examples. Then what is hyperconjugation? You also need to know about the classification of reagents. The organic reagents can fall into two main groups. First one is the electrophiles and the other one is the nucleophiles. So what are the different examples of these? Then after that, what are the different types of organic reactions? There could be substitution reactions or the addition reactions, elimination reactions or the rearrangement reactions. So you should know what actually happens in all these, and you should also know about different examples of each one of them. Then come to the types of mechanism, reaction mechanism. There could be polar or ionic mechanism or the free radical mechanism. So what are these two mechanisms and how do they work? With examples. Then what are the energy requirements for organic reactions? They could be exothermic or endothermic. Then how is the activation energy defined for the reaction? Then the graphical representation for both the exothermic and endothermic reactions. Then what is a transition state and what will be the graphical representation when the reaction intermediate is involved in the reaction. Then you need to go through in detail of some important mechanisms. For example, mechanism for substitution reaction, the example of free radical substitution reaction. What are the different steps like the initiation step, propagation step and the termination step with examples. And then also go through the example of electrophilic substitution reaction with example and what are the different steps involved in it. Then what is the mechanism for nucleophilic substitution reactions? It could be divided into two classes, SN2 reactions and SN1 reactions. Let's go through them one by one. First, the SN2 reactions, which stands for the bimolecular nucleophilic substitution, where the reaction is of second order. The rate determining step involves the participation of both the substrate and the nucleophile. Go through the reaction mechanism in detail with examples. And then the SN1 reaction, where the rate is dependent on the substrate and the reaction is of first order. Then what are the different steps involved in this kind of mechanism with examples. After this was the mechanism of elimination reaction, and in what are the classes in which it could be divided, like the E2 reactions and the E1 reactions. First, picking up the E2 reactions, it stands for the bimolecular elimination. Go through the example and the detailed mechanism. Then the E1 reactions, it stands for the unimolecular elimination. Go through the examples and mechanism and what are the different steps involved. There are major two steps involved in the process. Then what is the Steric rule? You should know about this rule in detail, and according to this, what would be the main product after elimination. After covering this, you need to cover the mechanism for addition reactions. First of all, the electrophilic addition reactions. What are the different steps involved in this with examples. Then what is Markovnikov rule and how it is associated with electrophilic addition reactions. And you should also go through some examples of this. Next is the mechanism for the nucleophilic addition reactions. What are the different steps involved in this? Then you need to go through the guidelines for writing organic reaction mechanisms. So there are a few points regarding this, so go through them. It will be helpful for the reaction mechanisms. Then you need to also cover the reduction and the oxidation reactions, the general idea about them, and a few examples. Also go through some typical reduction reactions like the catalytic hydrogenation and reduction with lithium aluminum hydride and the reduction with metals. So go through them, the mechanisms in detail and with examples. Then some typical examples for oxidation reactions. For example, how alkenes are oxidized to glycols with cold dilute potassium permanganate, or the treatment of alkenes with hot alkaline potassium permanganate, and maybe the alcohols and aldehydes when oxidized with a mixture of potassium dichromate and sulfuric acid, ultimately yielding carboxylic acids. So these were the few important mechanism examples, so just go through them. Then what are organic acids and bases? They are defined according to the Bronsted-Lowry and Lewis concepts of acids and bases. Let's go through them with examples. There are few important effects and rules related to the organic reaction mechanisms. For example, like Hoffman and Zaitsev rule, Markovnikov rule, and the Kharash effect. So go through them. What are these and how do they affect the reaction mechanism? For example, the Kharash effect, which is for the metal catalyzed free radical addition of CXCl3 compounds, where X could be chloride, bromide, or hydrogen, to alkenes. So these rules and effects are important and could be asked in the exam. So go through them thoroughly.